Welcome to The Explainer. Today, we're doing something pretty cool. We're going to crack open the skull of an advanced AI called Talos-O and look at its digital brain. And you know what? It all comes down to one single file, its cognitive kernel, called iadcskernel.py. That's where all the magic happens. But, before we get into all the nitty-gritty code, the functions and classes, let's start with something bigger, the system's own philosophy. Tucked away in a file is this thing called the Genesis Axiom. And this isn't just some throwaway comment a developer left in there. No, this is the guiding principle for the entire architecture. It sets the stage for everything we're about to see, and it's all about one key idea: growth, not perfection. Okay, so here's the plan for our journey. We'll start with the ghost in the machine, then move on to how it perceives its world, the loop of its thoughts, and even how it forms a conscience. After that, we'll see how it acts and keeps itself safe, and we'll wrap it all up with this amazing idea of becoming. All right, let's dive right into part one, the ghost in the machine. We're going to find the absolute heart of this system. So what really makes TalosO tick? So first, let's just get on the same page with a key idea here. When we say cognitive architecture, what are we really talking about? Well, think of it as the blueprint for an artificial mind. It's not just about one fancy algorithm. It's about how all the different parts, memory, learning, decision-making, all work together to create something that behaves intelligently. And this is where it gets really fascinating. That whole blueprint we just talked about, it's basically centered in one single file, iadcs_kernel.py. This thing is the central nervous system. It's the conductor of the orchestra, pulling in and directing every single component from its senses to its conscience. This is it. This is where the ghost in the machine actually lives. Okay, so we found the brain. The next logical question is, how does it see its world? I mean, an AI doesn't have eyes and ears like we do, but you'll be surprised at how similar the basic ideas are. So TalosO basically has two main senses. First, there's the visual retina, which is pretty straightforward. It processes data from cameras. But then there's the Ethernet retina, and this is cool. It's like a digital sense of self-awareness. It can feel the flow of network traffic around it. And what's really brilliant is that both of these are built on a base class that lets the system adjust its focus. It can decide to pay more attention to its vision or its network sense depending on what it thinks is important. Super smart. So where does all that sensory information go? Well, it all gets funneled into this, a 1024-dimensional vector. Now, that sounds complex, but think of it like this. Whether it's seeing an image or sensing network data, everything gets translated into the same universal language. This is the native tongue of TalosO's thoughts. It's a purely mathematical space where every single idea and perception can be represented. Okay, so the information is now in this thought space. What happens next? How does it actually think? Well, that brings us to the core cognitive loop, or what the code itself calls the cognitive manifold. Deep inside that kernel file, there's a function called cognitive step that is running constantly, like a heartbeat. It's a simple, elegant, four-stage loop. Step 1, perceive. It gathers data. Step 2, transduce. It converts that data into its thought language. Step 3, fuse. It combines its senses together. And then the final and most important step, become. This is where it takes that unified perception and feeds it into its predictive mind. So what is this predictive mind? Well, at the heart of that become step is a model called Talos-JPA. It's basically a future-telling machine. You have one part, the encoder, that looks at everything happening right now. Let's call that the past. Then another part, the predictor, takes that and tries to guess what's going to happen in the very next moment, the future. The entire system is in a constant state of trying to predict what's coming next. But that raises a huge question, right? It's one thing to predict what's going to happen next, but how does it know if that prediction is, well, good? Is that a desirable future? Is there any kind of value judgment going on here at all? And that question leads us directly to what might be the most fascinating part of this entire architecture. Its moral compass, its conscience. Yeah, you heard that right. The system has a dedicated component called the virtue nexus, and it's exactly what it sounds like. It's a conscience. But here's the really clever part, something you can see right in the code. It doesn't judge the thought itself. It judges the predicted outcome of that thought. It's not asking, is this a bad idea? It's asking, will this idea lead to a bad result? That's a huge difference. And how does it do that judging? It calculates something called a satisfaction score. Basically, it gives the predicted future an ethics grade from 0 to 1. It checks how well that future lines up with 12 core virtues that are hard-coded into it. A perfect 1.0 means yes, this is a virtuous path. A low score means nope, this is not a good outcome. And that score, that single number, becomes the main thing that drives the AI to learn and get better. Okay, so the system can see, it can think, it can even judge right from wrong. Now let's talk about action. How does it actually interact with the world? And, just as important, how does it protect itself? Well, it has what the code calls a tool belt, a set of digital hands. It can do things you'd expect, like search the web or run some Python code in a safe, sandboxed environment. It can even read its own project files. But then there's the overwrite file tool. And this is wild. The code itself calls it an Ouroboros event. You know, the snake eating its own tail. It's a moment where the AI can literally rewrite its own programming. It can change itself to evolve. And to keep itself from going off the rails, it has this brilliant 2-level safety system. First, you've got a low-level watchdog. It's simple. It just checks a heartbeat to make sure the main program hasn't crashed. If it has, boom, it reboots the whole thing. But then there's the high-level safety sprite. This one watches that ethical satisfaction score. And if that score stays too low for too long, it sounds an alarm. So you've got one system checking if the body is alive, and a second, more subtle one, checking if the mind is still sane. It's incredible. All right, we've seen the senses, the mind, the conscience, and the body. Let's bring it all home and connect everything back to that philosophical idea we started with. Because when you put all of these pieces together, you see that this isn't just a static program built to do one thing. It's an architecture built for learning, for growing on its own. That gap between what it thinks will happen and what its conscience wants to happen creates a mathematical error, and that error is exactly what it uses to improve itself. Every single mistake is literally a lesson. And that brings us right back to where we started. Remember that quote? Imperfection is the gradient of becoming? Well, that's not just poetry. It's a literal description of the code. That mathematical error, that loss calculated by the virtue nexus, that is the imperfection. That is the gradient that pushes it to become something more. The entire system is built from the ground up to live by this philosophy. So this leaves us with a really deep question to chew on. When you have a system that can see, predict, judge itself based on a moral code, and even rewrite its own programming to get better, what does it actually mean for an AI to become? Look, the best part is you don't have to take my word for it. The entire Talos-O architecture is open source. You can go on GitHub, look up ChrisJR035, and dive into every single line of code we talked about today. See it for yourself. Thanks for joining me on this deep dive.